have this first example problem. The company loaned 60,000 pesos to be used for constructing the new comfort room. The bank charges 3% interest compounded monthly. If the company paid a total of 69,697.01 pesos, how long did they pay the whole loan? So we have a problem involving compound interest. So we have this clue word, compounded monthly. So first, let's identify the given values. So we have here the loan. So this is the principal amount, which is 60,000. Another given, we have the interest. So this 3% interest compounded monthly. So that means we have I raised to 12. So because our period or the frequency is monthly. So we have this 3%, or when we divide it to 100%, we get the decimal, we have 0.02. So our M here again is 12 because it's monthly. And lastly, our future value or the total amount that the company paid is 69,697.01. So, what is the required or the missing in this problem? So, the question here, how long did they pay? So, we need to find the time or the length of time before they got paid the loan. They paid the loan. So we have time in years and our N. So for our solution, we have N equals to M times T. So we have missing T and N. We just have M. Now, let's take a look at another formula wherein we have involved future value for the compound interest, which is equals to P, or the principal amount, plus P times 1 plus our J, or interest rate, which is the quotient of the rate over the frequency of conversion. So we have raised to N. So our N is M equals M times T. So how can we get the value of N given we have P, F, and we have the formula for J is equals to I is divided by 2N. So we have this given and this given, so we have the J. So this is the missing in our equation. So how can we get that? So let's solve for the value of N. So in solving this equation, so we have this given this, and this. So we have an example here of logarithmic equation. So if we are going to recall the log of log to the base b x raised to n is equals to n log to the base b of x. So we can apply this to this exponential function. So let's divide both sides to p. So we have f divided to p, then p divided by p, divided by p, we have 1. So we have remaining 1 plus j raised to n. So we have f over p equals to 1 plus j raised to n. So we can get both sides the logarithmic. So what we do to the left side, we also do to our right side. So this logarithmic function is equivalent to n log of 1 plus j. So log of f divided by p. So to get the value of n, we just divide both sides to log of this value 1 plus j. So log 1 plus j. So our n now here is log of f divided by p over log of, so we have this cancels out, that's why we have the remaining n to our right side. Then we transpose it to the left side. Then this values to our right side, we transpose left side, we transpose it to the right side. So we have the denominator log 1 plus j. So we have values for our f. So that is 69,697.01. We have value for our principal value, which is 60,000. We have value for our j, which is the I raised to divided by 2m. So let's substitute. So we have n is equals to log of f. Our f is 69,697.01 divided by 60,000 pesos all over log of 1 plus our j is 0.03 divided by 12. What is this value of log? 69,697.01 divided by 60,000, we have equals to 0.065 divided by the log of 1 plus 0.03 divided 12, we have 0.00108. So let's divide these two values. We have n is equals to 60.185, or when we round it off, it's 60. So meaning there are 60 times. So our unit for n, since we have n is equals to mt, and our m here is months, 12 months. So we have 60 months. So how can we get the value of t, or how many years? So we just have to divide both sides to m. So our t is equals to n over m, which is our n is 60 months, 60 times rather, divided by 12. 60 months. We have 60 months divided by 12, that is 5 in years. So we have t is equals to 5 years and n is equals to 60 months. So this is the time, the length of time they paid the loan, which is 60,000. So let us have this second problem. How long it will take 1,000 pesos to earn 300 pesos if the interest is 12% compounded semi-annually. So we have to determine first our given. So the given in this problem, we have the principal value, which is 1,000 pesos. We have to earn, so this 300 pesos is our interest, the compound interest, which is 300 pesos. And our interest rate, which is compounded semi-annually. So our semi-annually, the m here is 2, because semi, then annually, then you have 2 in a year, because annually means in 1 year. So divide it by 2. So we have 2, which is equals to 12%. So how long it will take? So we have to find the length of time again, just like our previous problem, or our n. So in this problem, we have a given interest amount. So our compound interest is 300 pesos. So before, from our previous discussions, we know that the compound maturity value is equals to the principal value plus the interest in the compound interest. So we have here the future value, which is 1,000 plus 300. So that is our future value. 1,000 plus 300, that is 1,300 pesos. So let's substitute the values of F, P, and our I, and of course our M, which is 2. So again, our formula that we derived from the previous example, the first problem, we have log of F by P divided by all over log 1 plus J. So our F here is 1,300 pesos and our P is 1,000 pesos. So divided by all over 2 log of 1 plus J. Our J here is I raised to 2, which is 12%, or in decimal this is 0.12. So 0.12, our M, given M is 2 because we have semi-annually, so we have 0.12 divided by 2. So log of 1,300 divided by 1,000, we have 0.113943353. Then log of 1 plus 0.12 divided by 2, so we have 0.02530586526. So this values, if we get the quotient, we have n is equals to 4.503. So our n here, when we round it off, is equals to 5. So we have 6-month period. So because it's semi-annually, we have 6-month period. If you multiply it to, if we get our t here, we have n divided by m, so we have 5 divided by 2, we have 2.5 years. So this is the length of time it will take to earn the 300 pesos if you have 1,000 pesos investment with an interest rate of 12% compounded semi-annually. Example number 3. Due to pandemic, Wilson loaned 100,000 pesos from a bank and compound interest is done quarterly. If he will pay a total of 140,000 pesos after 2 years, what was the interest rate charged by the bank? So because of the pandemic, many people experience unemployment. So let's have this problem. We have given the principal value that Wilson loan from the bank is equals to 100,000 pesos. And the period of the interest is compounded, which is done quarterly. So our frequency here, since it's quarterly, how many quarters we have it, how many times it will be charged, or the interest will be charged in a year, so we have 4. If he will pay a total of 140,000, so we have the future value or the maturity value 140,000. And the time here is given, which is 2 years. So we have t is equal to 2. The missing or the required in this problem is the interest rate. So we are asked what was the interest rate charged by the bank. So we have the I, which is raised to 4. So for our solution, so we have the formula F equals to P 1 plus J raised to N. So our J here is missing because our J is equals to I raised to 4 divided by N, or I raised to 4 divided by 4. So we have P plus I raised to 4 for our interest quarterly raised to N. So let's substitute our given values. So let's substitute our given values. So we have 140,000 for our F, 100,000 for our P. So we have 1 plus. So we have I raised to 4 over 4. And then we have N, which is our N is equals to M times T. So we have 4 times 2 years. So now let's divide both sides by 100,000 to eliminate this value and this exponential. So we have 100,000. 140,000 divided by 100,000, that is 1.4. So we have equals to 1 plus I raised to 4 divided by 4 raised to 8. So to eliminate, to eliminate these exponents, we can raise both sides to 1 over 8. Because 8 multiplied by 1 over 8, that will be equals to 1. So we have 1 plus I raised to 4 over 4 and 1.4 raised to 1/8. So manipulating these equations, we'll have 1.4 raised to 1/8, or in decimal, that is 0.125. So let's transpose the positive 1 to the other side. So we have minus 1 equals to I raised to 4, then divided by 4. 1.4 raised to 1.8, that is equals to 1.042956,042. Then minus 1 equals to I raised to 4 divided by 4. So to get the value of I raised to 4, we need to multiply this. So 1 minus 1.042956,042 minus 1, so we have 0.042956,042 equals to I raised to 4. So we multiply this. We multiply both sides to 4. So to eliminate the 4 here. So our I raised to 4, or the given rate, is equals to 0.1718241,688. Or if we round it off, we have 1718. Or in percentage, we just multiply it to 100%, we have equals to 17.18%. So this is the interest rate that is compounded quarterly. Problem number 4. If you will invest your own savings, at what rate compounded quarterly will it doubles in 10 years? So, in this problem, we have a limited years, which is a given. So, let's define first the given. Given here, so you have your principal value, which is your savings, and after 10 years, so our time is 10. So your future value will be times 2, or your principal value will doubles, or your own savings. So the question here, we need to find what rate. So at what rate compounded quarterly, so raised to 4 again. So we are going to find the rate wherein your savings will doubles in 10 years. So we have a missing given, which is n is equal to 4. Our given, which is because it's quarterly. So let's find your rate. Let's have the solution. Again, our f is equals to p times 1 plus j raised to n. And our j is equals to 1 plus, our j is equals to I raised to 4 raised to m. So let's substitute our given value. So our f is times 2 of our p. So we have 2p here. Then our p is given as is the principal value are your savings, the money. Then we have 1 times the I raised to 4 divided by 4, because that is our frequency of conversion. Then our n is 4 times the p we have, which is 10, because n is equals to m, 4 times 10. So that's it. So we will observe that we have a p, or the principal value, in our left side, and also p, we factor p in our right side. So we can cancel both sides the p. So we have 2 equals to 1 plus I raised to 4 over 4 raised to 4 times 10, that is equals to 40. So to get the value of I raised to 4, we need to raise both sides and remove this 40. So we have 1 over 40, 1 divided by 40. So our exponent is 1 over 40, because if we multiply 40, we'll have 40 times 1 over 40, that is equals to 1. So we have 1 here. So 1 plus I raised to 4 divided 4. So we have 1. So since it's 1, we can just not write it. So we have 2 raised to 1 over 40. So getting the value of I raised to 4, we need to manipulate these equations. We have 2 raised to 1 over 40, then minus 1, then we have I raised to 4 over 4. 2 raised to 1 over 40, that is equals to, so let's continue here, 1.0175. Minus 1. So 2 raised to 1 over 40, that is 1.0175 minus 1 equals to I raised to 4 So we have 1.0175 minus 1. We have 0.0175. So let's multiply both sides to 4. So we have 4 here equals to I raised to 4. So the value we have cancel 4. So we have I raised to 4 in our notes. The value of our I raised to 4 is equals to 0.070. Or if we multiply it to 100%, we have in rate 7%. So you need to find an investment which offers 7% compounded quarterly to double your savings in 10 years. This is our I, or the interest rate should be compounded quarterly. For our last example problem, we have example 5. What effective rate is equivalent to 7% compounded semi-annually? So we have here given 7%, which is your I compounded semi-annually, or I raised to 2. Or in decimal, when we divide it to 100%, that is equals to 0.07. And our M, or our period, conversion period is semi-annually, we have 2. So what effective rate? So we are looking for the effective rate for our I raised to 1, or the annual rate. The effective rate. So let's have our solution. So to get our effective rate, we can get first the maturity value of our given. So we have F is equals to P times 1 plus J raised to N. So we have here the F1. So our P, 1 plus I raised to 2. Then our M here is 2. Then 2. So let's say our T is 1 year. So we just multiply to 1. Then our second maturity value, which is for the effective rate, we have same principal amount. Then we have I raised to 1 over 1. And we have 1. So let's equate both these two. Equate these two equations. So we have F1 equals to F2. So we have P1 plus I raised to 2 over 2 will be raised to 2 equals to P. So our F sub 2, 1 is P is times 1 plus I raised to 1 all over 1, or we can just not write it raised to 1, or not consider writing it I raised to 1. So we have here both sides principal value, so they are equal, so we can just eliminate it. How can we get the I raised to 1? So we have given I raised to 2, or our rate compounded in compounded semi-annually. So we have 1 plus 0.07, which is I raised to 2 divided by 2 raised to 2 equals to 1 plus I raised to 1. So to get I raised to 1, we need to transpose this positive 1 to the other side, or subtract minus 1 to both sides. So we have 1 plus 0.07 raised to divided by 2 raised to 2 minus 1 equals to I raised to 1. So let's compute. Calculate the value. We have 1 plus 0.07 divided by 1, divided by 2 rather. So we have 1.035 raised to 2. Minus 1. So 1.035 raised to 2, that is equals to 1.07 minus 1. So that our I raised to 1 is equals to 1.07, 1225 minus 1 is equal to 0.07, 1225, or when we multiply it to 100%, we have equals to 7.1225%. So our effective rate is equals to 7%, 7.12%. This is our effective